If you watch many of my videos, then you'll know that I'm a bit of a fan of cheap Chinese kits and equipment, or at least I like to play with it and see how bad it is or how good it is. And this video is just a bit of fun. I saw this and decided that for the price I had to at least test it. Something that I've been kind of looking for in one form or another for quite a long time. And you probably know that I repair and restore a lot of vintage equipment, electronics mainly, and one of the things I'm always looking for is a decent CRT test monitor. And the reason for that is most of the equipment that I work on is computer based, and so there's a CRT display of some sort in it, and trying to hook up a CRT for testing is always a bit of a pain. Firstly, they're fairly fragile, bulky, heavy, and they tend to operate over fairly limited ranges, so trying to find one that's got a fairly wide range and isn't bulky and is easier to transport is always a bit of an issue. So you've probably guessed what may be in here, but it's not an LCD mock-up of a CRT, which there's quite a few of those about. I've bought quite a few of them and they never seem to work properly. I can't get them to properly sync with anything. They'll work at one very specific frequency and then shut themselves down if it's out slightly. A real pain to use. So I saw this and I paid £21 for this, delivered from China, so I'm not expecting a great deal from it, but I thought it might be a bit of fun, and I thought I might as well make a video of this and see if it actually does anything useful. So what's in here? I'll open it up, and this is a flat screen CRT monitor, and could have done with a bit of a clean before they sent it, but so I haven't really looked at this yet. But it's basically it's a bit like the old Sinclair flat screen TV type tube, in that it is actually a CRT, so it's a glass envelope CRT, heater, scan coils, all the works, but it's got a curved surface for the phosphor screen, obviously glass on front, and the idea is that it scans in a pattern that turns the beam into a rectangular image, but it's supposed to operate over quite a wide range of scan frequencies. Now, it takes a composite video signal, but that's very easy to arrange from most equipment. You just cobble together the H and V signals along with the chrome signal, and you can quite easily create a composite signal. The biggest problem is most CRTs only operate over or at least CRT monitors only operate over a very limited range of frequencies, so it's a real pain trying to find one that works with most vintage equipment, which quite often have odd scan frequencies. So I thought I'd try this. I'm quite surprised already by the apparent quality. It looks quite good. It's actually quite heavy. I was expecting something really light and flimsy. There are some surface mount components, quite a few on the back. Mixture of through hole. It is a plastic case. Not really a sensible part number on there to make any sense out of. It says VIS 4001D. But okay, we'll give this a go and see if it works. So to start with, I'm going to do what I normally do and hook up the signal generator to see if we can get any patterns on the screen. You've seen me do that before with real CRTs, standard CRTs. Let's see if we can get anything on the screen. I'm not holding out a great deal of hope. I don't even know if this will work at all, but I'll give it a go and we'll see what we can get. Okay, I've been tinkering with this for a little while. There is a spec sheet of sorts available for this, just shows the interconnections. So we've got power, ground, and then the composite video signal and ground, and then it needs a couple of pots, one for brightness and one for contrast. And I've just been playing with various resistor values and got some hooked up that seem to give a reasonable display, and it does actually seem to work. So I'm just going to dim the lights. I've got this powered from my new 01 ODP 6033 bench power supply, which is still working extremely well. And I've got the input set to 14 volts at 0.5 amps. So I'll power this up, dim the lights first. You can see a bit more of what's going on. I'll turn the supply on, and as you can see, it comes to life fairly quickly. I've also got it hooked up to my signal generator, so that's currently set to 16.45 kilohertz, and I've just got an arbitrary ramp waveform. As I say, you've seen me do that before in other videos, so I won't go over exactly how this is all configured. We'll switch this on, and hopefully you can see reasonably well that it's showing something reasonable on the screen. And it's got a bit of distortion. I don't know if any of the pots will allow me to adjust that, but it's relatively linear. It's got some quite good shape to the image. It's not as distorted as I was expecting. Bearing in mind this is a bit of a strange geometry, so the vertical bars that it should have are fairly vertical. They're reasonably straight. They're bits of barrel distortion, but quite acceptable. And I don't know how well this is coming across on the camera, whether there's flicker or not. There's no flicker evident at all in real life, and it's a very bright image. It's surprisingly bright, good contrast. And I was going to turn the lights back on. So that's quite a surprise, but of course that's not very interesting. So I thought we'd hook it up to something a bit more interesting, and as a good experiment I thought we could try our trusty ZX81. So I'll get this hooked up and see if we can get this to come to life. Okay, I've got the ZX81 hooked up. Just a couple of power cables soldered directly to the ZX81 board. I've got the input to the modulator, the RF modulator, connected to this yellow wire. Obviously I don't want the output of the modulation, that's for going into a television, so that wouldn't work. What I want is the composite video, and that's what's fed into that modulator, so that's what this yellow wire is connected to. That goes around and is connected to the composite signal input to the monitor. So I should now be able to power this up, and in theory we should be able to run the ZX81 directly on this monitor. So I'll power up the monitor first. I'll dim the lights again, power up the monitor, and that's come to life. And now I'll power up the ZX81, and it has actually come to life. What I'll do now is I'll zoom in the camera and see if we can actually write a small test program, and surprisingly the quality of the image on the monitor is extremely good, very sharp and crisp, so that looks quite good. I'll just move the camera closer so you can have a look, and it looks like this is actually going to work much better than I'd expected it to. Okay, well I've got you zoomed in. Unfortunately I can see through the viewfinder of the camera that there are some bars showing on the camera image. Sorry about that, I can't seem to do much about it. It's not visible in real life. It's just one of the problems in trying to video a real CRT display, which this is. It's not an LCD, it is an actual CRT. Hopefully you can see the image clearly enough to see that it's quite nice and clear. So what I'm going to do now is just quickly enter a test program, and we'll see how it looks once we get some more text on the screen. Okay, I've got our short test program entered. You can see that at the top of the screen we've got our program, and the geometry and scanning of the screen seems to be correct, so we are getting the text right at the top of the screen. It is a bit distorted. I might try and tinker with some of the pots, see if that can be corrected. It's not too bad, just be nice to have it a bit more correct. The contrast and brightness is extremely good. I'm very impressed with that, and the blacks are very black, and the parts that should be white are quite nice and bright. It's not coming across quite as well on the camera, but we'll now try and run our program and see how well it works. So, as you can see, works quite nicely. The text is very readable, nice and clear. The focus is good all the way from the bottom right to the top, and so I would call that a success. I'll just move the camera back away so you can have a quick final look. Okay, so I'm impressed. I wasn't really expecting much from this. I wasn't even sure it was going to work at all, but it's working extremely well. You can see, apart from the slight distortion, it is working fine. Now, I did earlier try a whole range of different scan frequencies, and it seems to work from everything from 1 kilohertz up to 35 kilohertz, which is amazing, and it does that being able to lock on to the signal. As long as the signals are a sensible multiple, so it won't work on every single intermediate frequency, but every 500-600 hertz it was locking in quite nicely. So that's extremely promising. It means it's going to hopefully operate over a very wide range. The input signal level also seems to be very forgiving. I tried this from 2 volts composite input right the way up to 16 volts, and that would normally cause all sorts of problems, but this seemed to handle it quite well. Anything below that and it starts to distort very badly, anything above that and it starts to break up. But very impressed. It's better quality than I expected. I'll probably put a few pots on here, make a small enclosure for it to enclose the electronics, but I can see that this will be extremely useful. It's nice and compact, easy to fit this onto a bench, and you can see, if you're familiar with the ZX81, roughly how big this is, and I think it's going to be a very good addition to the lab. It's certainly beats having a huge monitor that you've got to find space for, and also because it's obviously handheld, or can be handheld, you can move it around as you're working on the equipment. So yeah, very good buy, and at £21 delivered, I'm extremely impressed. If you're interested, it's drawing about 0.3 amps at 14 volts, so about 4 watts, and that's very reasonable. It's even obviously possible to make this battery powered. If it's only drawing a few watts, then a small lithium or a couple of lithium batteries, and it'll run for several hours on a single charge. So I may well end up doing that. And another advantage of that approach is that it would be isolated, so it wouldn't need special precautions to stop blowing something up. You can just assume it's floating, so I may well do that. Okay, so that's it for this video. Just a bit of fun, much better than I expected, and that does sometimes happen. You buy cheap things and sometimes they do actually surprise you.